Hi, today we're going to start chapter 7, which deals with exponents. Our objective today is to use and apply zero and negative exponent rules. You already know how to simplify expressions where powers are being added. Remember, if an exponent is being raised to the same power, they are like terms if it's the same base, I should say. So let's take a look at these. I have 3x. And I have negative 6x. I can add those. 3x and negative 6x is negative 3x. I also have 5x to the second power and negative 2x to the second power. Again, I can combine those because they have the same exponent, same base raised to the same power. 5x to the second power, negative 2x to the second power is a positive 3x to the second power. And lastly, I have negative 4x to the third power and a positive 7x to the third power. Again, I can combine those because they have the same base raised to the same power. And I end up with a positive 3x to the third power. Now I cannot add my negative 3x, my 3x to the second power and 3x to the third power because these are not like terms because they're not raised to the same power. Today, we're going to learn how to simplify expressions where powers are being multiplied and divided. Well, this chapter, not just today. We're being multiplied and divided. We have two main rules we're going to learn today, the zero exponent rule and the negative exponent rule. Let's talk about the zero exponent rule first. Let's look for a pattern here. I have 2 to the third power. Well, that's 8. 2 times 2 times 2. 2 to the second power, that's 4. 2 times 2. 2 to the first power is just 2. Look at this pattern. As my exponent goes down 1, what it equals is divided by 2. So 2 to the third power is 8. 2 to the second power is 4. 8 divided by 2 is 4. When I divide by 2 again, I get my 2. So 2 to the first power is just 2. If I take 4 divided by 2, I get 2. So if I continue that pattern, what will 2 to the 0 power be? Well, 2 divided by 2 leaves me with 1. Let's see if that continues. I have 3 to the third power is 27. 3 to the second power is 9. 3 to the first power is 3. In this case, every time my exponent goes down by 1, I divide by 3. 27 divided by 3 is 9. 9 divided by 3 is 3. So, if I take 3 and divide by 3, I will get 1. So, it worked again. So that's our zero exponent rule. Any number to the 0 power is equal to 1. Let's practice applying this. I have negative 4 to the 0 power. Now I want to point out, we said that our exponent applies to what it's touching. Here it's touching the parentheses, so I'm raising negative 4 to the 0 power. Negative 4 to the 0 power will just be 1. Here I have 5 times n to the 0 power. Again, it's my n that's being raised to the 0 power because that's what it's touching. My 5 is not in parentheses with the n, so it's only my n that's being raised to the 0 power. So that would be the same as 5 times 1, or just 5. In my next example, I have 7 being raised to the 0 power. So I have 1 over 1, which is just 1. So we did our first rule. Our first rule is just any number raised to 0 power is equal to 1. Sorry, it's equal to 1. Now let's look at our negative exponent rule. Let's continue the pattern. We got 2 to the 0 power. Well, what would 2 to the negative 1 power be then? Well, if I divide 1 by 2, I get 1/2. If I divide 1/2 by 2, as I continue my pattern, then 2 to the negative 2 power would be 1/4. If I divide 1/4 by 2, 2 to the negative 3 power would be 1/8. Let's look at our 3's. If I divide 1 by 3, my 3 to the negative 1 power would be 1/3. If I divide 1/3 by 3, my 3 to the negative 2 power would be 1/9. And if I divide 1/9 by 3, my 3 to the negative 3 power would be 1/27. So what do you notice? Notice that I have 2 to the third power is 8. 2 to the negative 3 power is 1/8. 3 to the second power is 9. 3 to the negative second power is 1/9. 3 to the third power is 27. 3 to the negative third power is 1/27. So, in other words, 2 to the negative 3 power, I would just move that 2 to the third power downstairs and make it a positive 1/8. The negative exponent in the numerator will move downstairs. So we take this 2 to the negative 3, move it downstairs, it will become a positive 3, and then we have a 1/8. Now if I have a negative exponent in the denominator, let's say this was 2 to the negative 1/3 in the denominator, I would move it upstairs, and the base stays the same. So let's practice that. I have a to the negative n power. Well, as I said, I want to take those negative exponents and move them downstairs. So my a to the nth power would be downstairs. It becomes positive when it moves downstairs. But in this case, what's in my denominator? It's that hidden coefficient that's right here. It's a 1. How about 4 to the negative 3 power? Well, I would take, I'm still going to keep a 1 on top, and I'm going to have 4 to the third power downstairs, and 4 to the third power is 64, so it's 1/64. What about this one? Notice it's not in parentheses, so I'm going to move it down, my 2 to the third power downstairs. I'm going to have the 1 upstairs, but it is negative. This expression is negative. It's the opposite. So now I have 1/2 to the third power is 8, but it is going to be negative because it isn't negative 2 to the third power. It is the opposite of 2 to the negative 3 power. Let's do some more practicing. This time, some of our exponents are in the downstairs, so we're going to move them upstairs. I'm going to move that x to the third power upstairs. I'm going to end up with 1 x to the third. When it went upstairs, it became positive. Now, we don't usually write a 1 for a coefficient, so that's the same as x to the third power. In this case, I'm going to take my n to the negative 4 and move it upstairs, and that will become 2n to the fourth. And my last one, I'm going to take my a to the negative 2 and move it upstairs. Again, I don't usually write my coefficient of 1, so I'm going to put a to the second power when it goes upstairs, but I do have this negative, so it is going to be negative a to the second power. Let's try a few more. I have 3 to the negative 4 power. I take this, move it downstairs, and make it 1 over 3 to the 4th. Yeah, if there's nothing in the numerator, it will be a 1. 3 to the 4th is the same as 81, so it's 1 over 81. In this case, it's 4 to the negative 2. I'm going to move that upstairs. So I'm going to, since I had that 1 there, 1 times 4 to the second power will just be 4 to the second power. And I had a negative, and it's going to stay there. It wasn't in parentheses. In this case, I do have parentheses, so I need to keep those parentheses. Oh, by the way, negative. This would be negative 16. I didn't finish that one. This would be negative 5 to the third power. But I had to have moved downstairs. I should have written my 1 first. I don't have much room to write down here. Which would be negative 5 times negative 5 times negative 5, which is negative 125. And I could write 1 over negative 125, but usually when we do that, we put the negative in the front. 1 over 125, and it's a negative fraction. Either way is acceptable. This way is probably where you'll see it more often. Okay, let's try some more. These ones are a little trickier. We're going to look for our negatives and move them upstairs or downstairs. So, draw my fraction bar. My a to the third power, negative third power, will go downstairs. My b to the fifth will stay where it's at. C to the 0 power is just 1. And so you're multiplying by 1. So I'm going to end up with 4. And b to the fifth in my numerator. And then my a to the negative 3 moved downstairs and became a positive a to the third upstairs. And my c goes away because it's just 1. You multiply by 1, it is just the same thing. Identity property. Okay, let's look at my next example. In this case, I have z to the negative 4. This is going to go upstairs. But my y to the negative 1 is going to go downstairs. So I will have x to the 6th power staying where it's at. My y to the 1st power going downstairs. When you have a power of 1, you usually don't write the 1. Then my z to the negative 4 will go upstairs and become positive z to the 4th. And now I no longer have any negative exponents. Okay, another example. My p to the negative 5 will go downstairs. Q to the 0 power is just 1, so I can pretty much ignore that. My r to the negative 1 will go upstairs. And my negative 4 raised to the 2nd power will also go upstairs. So I'm going to end up with 4, negative 4 I should say, negative 4 to the 2nd power. And r in the numerator, and p to the 5th in the denominator. Now negative 4 to the second power is negative 4 times negative 4. That's positive 16. R. Notice I didn't write R to the first. You usually don't write a 1 when that's your positive exponent. And in my denominator, I will have p to the 5th. That looks kind of more like 5 than a exponent. Okay, now I have an example here. Let's simplify it before I go through substitution. But I'm saying m is negative 4 and n is 2. But I highly recommend simplifying before you do that because you might clean things up quite a bit. So I have negative 7. That is not being raised to the negative 3 power. Only my m is. So my m is being raised to the negative 3rd power. So it's going to go downstairs and become a positive m to the 3rd power. And my n to the 3rd power staying upstairs. Okay, and I'm going to put in 2 for n and negative 4 for m. So I have negative 7. When I plug these in, I usually put them in inside parentheses so I know whether it's a positive or a negative number that I'm raising to a power. I have 2 to the 3rd power. Then I have m is negative 4. That I'm also raising to the 3rd power. Well, 2 to the 3rd power is 8, so I have negative 7 times 8. And negative 4 to the 3rd power, negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. Now I have negative 7 times positive 8 is negative 56 over negative 64. I have a negative and a negative, so that will cancel out and leave me with a positive because a negative divided by a negative is a positive. And I can simplify 56 and 64 with 8. So this would become a 7, and this would become an 8. So my final answer to this whole thing is 7/8. Lots of steps. But you don't want to lose track of any of them. Okay, so let's do a quick summary. Any number to the 0 power is equal to 1. A negative exponent in the numerator will move downstairs and the exponent will become positive. Negative exponent in the denominator will move upstairs. And the base stays the same. That's it. Have a great day.